We'll go to Mars, Saturn, the stars, the galaxy.
Drifting right. Watch it.
Eagle, this is Houston. Do you copy?
You need to remind them of Apollo 11. We came in peace for all mankind.
Ready to fire.
We need to live up to that.
What did they get right? What did they get wrong? Also, why haven't we been back to the moon in almost 50 years? There are 12 dudes that walked on the moon. Only 4 of them are still alive, and the youngest one's 85. Why? Why have we not been back? We figured out how to do this in the 60s. It's 2021, we haven't been back yet. How could this have gone differently? Alternate routes we could have taken, alternate space history. That's what For All Mankind's about. Let's do it. Wreck them up, knock them down. So in season 1, the big deal is we're gonna make a moon base. And we're going to the South Pole. There's some inaccuracy in that they're like using standard Apollo hardware to go land on the South Pole, which I don't think they could have done. They couldn't go high latitudes. Okay, I'm not gonna break your balls over that one. We get to season 2, and we have the Seadragon. Oh my God, the Seadragon. Every nerd just crazy. It's enormous, look freaking thing. Okay, so surprisingly enough, it's real. At least it was a real proposal. It was a real idea, really studied. They were gonna work on it. Got canceled. It seems insane, but it was a real serious proposal idea. It's a big dumb booster. So the big thing driving rocket design is the Selekowski rocket equation, named for Konstantin Selekowski, who just doing thought experiments in Russia in like 1893. He figured all this stuff out, space stations and how they would work and rockets and how to do the math. Figured that all out by himself, doing thought experiments. Crazy dude. Amazing. Anyway, the rocket equation he came up with, the key thing you need to zero in on is the mass fraction. That is, you want a rocket to be entirely propellant and payload. Everything else, the mass of the structure, the engines, the fuel tanks, all that stuff, the lighter the better, all right? And this is often referred to as the tyranny of the rocket equation, that it's really hard to work around. It's really difficult. And so most of the time when you're designing rockets, you look at examples of rockets, what you see is they're trying to make them as light as possible. When you're doing that, that means using materials that are difficult to work with or expensive, or manufacturing techniques that are complicated, exotic, expensive materials. So it's this big thing of like, how do you make it lightweight and strong and survive temperature extremes while also like holding in cryogenically cold stuff. It's hot and cold, high pressure, aerodynamic forces, but we're also trying to make it very light without making it weak. This is tough. Engines, rocket engines there's just so much engineering goes into them to make them the highest specific impulse you can get. It's the other part of the rocket equation. Basically, bang for your buck you get from your fuel. The higher the chamber pressure, the hotter, the faster, the harder. Rocket engines are just at the very limit of material science and engineering. They're finicky and delicate and hard to make, hard to manufacture, and they are prone to just blowing up. They're expensive, is the point. Seadragon says, screw all that. You know what we're gonna do? Big dumb booster. Those rocket engines, turbo pumps, all the complicated plumbing, get rid of all that. Pressure fed, that is, it's basically a super soaker. You just like pressurize and push the fuel and the oxidizer through it. Very simple. Why don't most rockets do that? Because pressure fed is not as efficient. So your payload's gonna be smaller, and that's a problem on any normal sized rocket. Seadragon says, screw that. We're making it out of corrugated iron and steel, and it's a brick like a submarine. It's like a tank. Doesn't need to be light and delicate. That way, cheap, easy to manufacture, it's rugged, great. Not efficient. Rocket equation is not happy. But here's the deal. If you have a big, inefficient rocket with inefficient engines, overly heavy tanks, but it's enormous, you could still have a big payload, right? If you scale it up. So the big dumb booster, yeah, it's huge and it's too heavy, but it's so freaking big that even though the payload mass fractions aren't great, you still get an enormous payload. And the Seadragon, that engine was so big, it was supposed to make 80 million pound force. The Saturn V, 7.5 million. Okay, so it's more than 10 times the thrust of a Saturn V. Crazy idea, right? And then there's like the sea launch mechanism, which, you know, theoretically would work. How do you fuel it up? You use an aircraft carrier with electrolysis on seawater to make your hydrogen and oxygen. Theoretically, you can do it. As an example, the Atlas rocket, the original one, imagine an aluminum can, like a Coke can, unopened, try to crush that. Good luck, you're not doing it. Opened and empty, you can easily crush it, right? The Atlas rocket was like that, right? And this is a clever engineering technique. As long as it's pressurized, it's quite strong. The problem is you have to transport it, you've got to move it around, you got to put a payload on it, you got to fuel it up, all these things. If you ever lose pressure, it just like folds on itself and buckles. Like that's difficult to work with. That's gonna be expensive to like constantly need it pressurized. These are the kinds of clever engineering things that improve your payload, but probably make this whole process harder and more complicated and expensive. Now, whether this sea launch thing is really the way to go, I don't know. I don't know if they could have really made this giant single chamber engine work. Sure, it's pressure fed. I don't know about combustion instability, which was a huge problem in the F1 engines in the first stage of Saturn V. They were able to sort that out, but on like a much, much smaller scale. I don't know if they're sorting that out here. Also, transporting this thing around, they said it would be reusable, and everybody in the world's like, oh, our rocket, you pop some parachutes and we'll reuse it. Easier said than done. If it's me and I'm trying to make big dumb boosters, I'm going solid rocket boosters, because those things are basically just like a metal tube full of spicy goo. That's all it is. It's like fireworks. Metal tube with spicy goo. Oh, you fire it up. There's no engine, there's no gas generator, turbo pumps, none of that stuff. Cluster however many you need for your specific launch. That's a big dumb booster. And again, part of the Seadragon and a big dumb booster approach. If it blows up, it's no big deal because we're not putting people on it. There's the AJ260, that's Aerojet, 260-inch diameter rocket. They made a half-length one. This thing made 4 million pounds of thrust. Again, out of a metal tube full of goo. 4 million pounds of thrust. That's like 2.6 repeating F1 engines.
The Florida Everglades was the site of the second test firing of a powerful solid fuel rocket motor. The 8-story tall motor spewed out a pillar of white-hot flame from its exhaust nozzle. The so-called large solid burned 840 tons of rubber-like fuel at a rate of 6 tons per second.
So you could have built rockets out of that. There's studies to replace the first stage of the Saturn with that. The big dumb booster approach is probably a good idea if you have a lot of mass to send up that's not with people in it. All right, the space shuttle going to the moon. Your beauty shot from season 2, space shuttle to the moon. Oh my God, this makes no sense. When the space shuttle finishes its burn with the external tank, ditches that, it uses its orbital maneuvering systems, OMS. There's little rocket pods to get into its final orbit. Eventually it'll use that to slow back down to then re-enter. This OMS pod has 300 meters per second of delta V. So if you boost the space shuttle as much as you can with those OMS, you get 300 meters per second more velocity. To get any spacecraft from Earth orbit to lunar orbit takes about 4 kilometers per second of delta V, 4,000 meters per second. The space shuttle could do 300, okay? It's nowhere near enough. Now they mentioned in the show that they refuel it. That's okay. The OMS pods cannot hold anywhere near that. They can hold enough for 300 meters per second. So basically, if it's the OMS pods, they're saying that like this entire payload bay has got to be full with more fuel tanks, probably even more strapped on. This is insane. That's like if you're watching a movie and they drive from LA to New York in a just normal car that has 4 gallons of gas in it and they don't have to stop to refuel, okay? That's how far off this is. Now the other thing is the shuttle, you could keep the external tank on. You could add hydrolux to that, so maybe you could refuel that and then go off to the moon from there. Okay, here's the problem with that. I did the math. The space shuttle in orbit, it's about 100 metric tons. In order to boost that out to lunar orbit, requires about 150 metric tons of fuel. All right, liquid oxygen and liquid hydrogen. All right, so the space shuttle, you've launched a space shuttle. It now needs 150 metric tons of fuel, okay? Saturn V cannot put up 150 metric tons of fuel. So in order to have this shuttle go off to the moon, you have to launch a space shuttle, you have to launch an upgraded Saturn V just full of fuel. You've got to do this fuel transfer there. Then you can go to the moon and do this. What is it? It's a crew rotation? Maybe they're just bringing some stuff. Except it doesn't land on the moon. It only meets up with one of these lunar lander shuttles, so they can't have that much stuff. This doesn't make any sense. Like, why would you need this giant space plane? And in any case, if you could put 150 metric tons of fuel, you send it off to lunar orbit, you send the space shuttle back to Earth, And it burns up on re-entry because it cannot possibly handle the heat of re-entry from a lunar orbit. No way in hell. While you're going from like 17,000 miles an hour to 25,000 miles an hour, that's about doubling the heating. Okay, so space shuttle is designed for low Earth orbit re-entry. We're doubling the heating. So this just doesn't work at all, okay? Space shuttle makes no sense. The version of NASA in For All Mankind would never have built this space shuttle or designed it in this way. The real-life space shuttle is designed the way it is based on all these budget limitations and cutbacks and compromises. In For All Mankind, they've got way bigger budgets. They've got the Seadragon. There's all these reasons why it would not have come out that way, and I'll get into more detail on that in a second. So if your goal is you got to get crews from Earth to lunar orbit, there's a lunar lander shuttle that comes up and down. It's refueling at the moon, right? Okay. So you need a craft that can carry whatever, 7 people, 10 people, however many you need for your rotation. You need it to get out to lunar orbit and come back. What you would design is not a giant plane with huge wings, landing gear, no, it's so heavy. Instead, what you're gonna do is you're gonna make an Apollo but bigger, a Soyuz but bigger, a capsule approach probably. And if you wanted to go with like a flyable, like a lifting body or something, you go like the HL-20, X-38, the Dream Chaser, you might design something like that. So it would have some ability to steer, land on a runway, okay? And it's still nowhere near the size of this giant space shuttle. If it's me, I'm going with the HL-20. See here, it looks pretty shuttle-y, so you could still get your nostalgia factor going on. The HL-20 was supposed to be about 10 metric tons. Now let's say we want to upgrade more cargo, room for more crew, you know, if you actually build the thing, it just weight growth that happens. Maybe we put some missiles on it, I don't know. Let's call it 20 metric tons. Off to the moon, come back. 20 metric tons, not 100 metric tons like the real space shuttle. So what does it take fuel-wise to get that thing off to the moon, come back? 50 metric tons of fuel, okay? 50 plus 20, we're talking 70. So any launcher that can put up 70 metric tons into low Earth orbit can launch this thing and it can go to lunar orbit. We don't need 250 metric tons of launching, we need 70, which means a Saturn V could easily do it because that's 140 metric tons. A Falcon Heavy could just about do it. And this is, you know, very back of the napkin type stuff. In this alternate history, maybe they have a medium lift 80 metric ton launcher. We'll get to that in a minute. All right, the lunar lander shuttles. These are the shuttles. They look like lunar modules, like Apollo lunar modules go up and down from lunar orbit, land on the moon, back to lunar orbit. They're reusable and refuelable. Are these realistic? No, not really. So they're harvesting water ice on the moon. They're using electrolysis, turn into liquid hydrogen and liquid oxygen. That's rocket fuel. That's great. This is in situ resource utilization. This makes perfect sense. Here's the problem. Liquid hydrogen is very, very not dense, okay? Look at the space shuttle external tank. How big is it? Why is it that big? Because it's liquid hydrogen. If you see any rocket and it's like really big, it's because it's got liquid hydrogen. It's very not dense, okay? So if you're using liquid hydrogen, liquid oxygen, this thing is gonna have giant fuel tanks. And so here are some examples, some actual designs, lunar modules that would use liquid hydrogen, and look how big and bulky they are compared to the For All Mankind one. Doesn't make much sense. And also these are even staged, right? Staging is more efficient. You ditch half your spacecraft, you lose all that dead weight. And For All Mankind, it's a single stage, so it's not more efficient. I don't know where they're putting this liquid hydrogen. This doesn't look right. All right, the Pathfinder nuclear shuttle. We're getting towards the end of season 2 now. They've got a new upgraded space shuttle. It looks like a little bit more advanced version of the real life space shuttle, about the same size, but it's got nuclear engines. All right, are nuclear engines a thing? Yes, there's Project Nerva. Nuclear engines for rocket vehicle applications, Nerva. They really tested this thing. In a chemical rocket, you combine some stuff, they burn, there's a chemical reaction of some kind, and these more energized particles are flying out the back end, and that gives you your energy. In a nuclear rocket, you pass hydrogen through a nuclear reactor. It heats it up very, very hot, and then it spits out through the nozzle very, very high speed. And it's extra high speed because it's hydrogen and it's the lowest molecular weight. Okay, we don't need to get into that. Here's the thing though, nuclear rockets they use hydrogen. And again, liquid hydrogen, not dense, huge tanks. Do you see any fuel tanks on this thing? No. So they're saying what? That it's got fuel and it's like wings, like an airliner or something? I mean, those wings are a little chunky, but no, I'm sorry. Secondly, they're launching this thing from the back of a plane, subsonic, not very high altitude. So this air launch thing, not really helping very much. It's putting barely a dent in your delta V calculation here. People seem to think that air launching is like this huge shortcut. It's like, no. Like the key to getting to orbit is going 17,000 miles an hour sideways, right? So the first 600 is not that big of a deal. You still have to get up to 17,000. So it's not like this huge shortcut. This is why most rockets are not air launched. So the Nerva engines in real life, the real specific impulse is about double that you could get with like the space shuttle main engines, right? So it's double the efficiency. Okay, right? So maybe if you showed it launched like a normal space shuttle and it's like, oh, it doesn't need to refuel, it can like use that external tank for a while, that would maybe make sense. But launching off an airplane, this really doesn't make much sense. Additionally, nuclear rockets and really any rocket, kind of rocket, you know, like ion propulsion, any of these higher specific impulse, typically they're also lower in thrust, right? So like the lowest specific impulse you're gonna get with like a solid rocket booster. But those things, like we mentioned, spicy goo in a tube, they're not that efficient, but they can make a whole hell of a lot of thrust, right? So this is why you put boosters on at the beginning, because you need all out thrust in order to lift this big heavy thing up. Once you're in flight and you're going and you're losing weight, okay. So these really efficient engines are great for when you're already in space and you're just floating and you can burn an engine for 15 minutes, that's fine. But when you're taking off and you need to get going fast and high right away, not so good. I don't know if this thing's gonna really get up there at all. I mean, A, it's gonna run out of fuel in like a minute and a half, so it's definitely not getting to orbit. But suppose it had enough fuel, it's gonna take a long time for this to get up to speed, get up to altitude, and the longer it takes, the more you're gonna have gravity losses, more drag losses. So it's like you're losing some of your efficiency. So I don't know why they're doing this air launch thing. This really doesn't make sense. Unless they're saying that like this, we've just solved, they're hand-waving nuclear rockets to be like way more efficient than they really are, more thrust than they really are. They also have like more engines on the Pathfinder, and I thought, I mean, what would make more sense is if they had like scramjets or something, like SR-71 type engines or something that could get it going, you know, air breathing, get it going really high and fast, and then you kick in the nuclear engines, you know, maybe that would make more sense. I don't know what those engines are for because they don't ever use them. So maybe those are just like jet engines for when they're landing. I don't know. There's some wonky stuff with the T-38. Some of this flight stuff doesn't look right. Whoever over pandemic was drawing pixels didn't do a great job making this realistic. Some of the scale, like they go up and they come back down and it's as if they just climbed 30,000 feet and it looks like 40 feet. I don't know. Some of their like maneuvers, not great. Guns, we got guns in space. They're gonna need to make some more modifications. You're not just gonna show up to your moon base with an AK-47 and an AR-15. Like temperature extremes, giant bulky gloves, and like your trigger guard. They also have like optical sights on them that I don't think they can use anyway. So like you could have fun with it, but again, I think they went with the like nostalgia / attention grabbing thing of like, what about M16, AR-15 on the moon? So, and for all mankind, they're just way too concerned with in situ resource utilization. That's when you're like, I'm gonna use stuff around us to make things like, oh, we can make fuel out of the water here. They're too concerned with it. So for example, like taking water ice and then drinking it, turning it into rocket fuel, that makes sense. Okay, pretty simple to do. But they're talking about like lithium mining so they can make batteries. It's like, you're telling me that on the moon, you're gonna like take ore, you're gonna take these like lithium rich rocks and like smelt them and then make batteries? When you have the Seadragon, you've got a rocket that can put up 1 million pounds of stuff. Batteries? You're gonna make batteries on the moon? That seems like, how much equipment do you need to make that? All right, so they've got a nuclear reactor. Power, okay, makes sense. But then they're making weapons-grade plutonium. No. If you need some weapons-grade plutonium, you put it on your 1 million pounds to orbit rocket and you send 80 kilograms of plutonium, all right? You're good. You don't need like a giant nuclear reactor. This is like what did you launch, an aircraft carrier to manage this? How do you think you're making weapons-grade plutonium in a little tiny lab with test tubes? This is like if you're watching a movie and a guy's like, you know, I really want to eat a hot dog. And he could just go like buy a hot dog, and instead he goes and like by hand with parts makes a meat grinder and then he goes out and like makes a stick and hunts wild boars, and then he cuts off their lips and anuses and then like puts them in, goes through all this effort to make one hot dog. It's like, I mean, like, if you had a YouTube channel, I'd watch, but I don't think it's very efficient. All right, here's some things they could have used that they didn't. First off, Manned Orbiting Lab, or MOLE, which is this program to make like spy space stations. So let's go back to the 60s. We don't have spy satellites. So what do? We want to spy on the Soviets. We have flyovers, right? And then they developed the first spy satellites. The first ones the US comes up with are called Corona. Now think about this. You don't have digital cameras, or if you do, they suck. I don't know. So what do? You use film cameras, and then your spy satellite takes the film, puts it in a little canister, and drops it off. It re-enters, drops a parachute, and a plane catches it. Oh my God, like this is how we got photos from our spy satellites. They ended up launching 253 of these kinds of film canister spy satellites. Now, as you can imagine, these don't work super well. For one thing, these things aren't very smart. We don't know what they're shooting. So like they could be taking shots of clouds. We don't know. And then we can't recover all these things. We, just can't find them. They malfunction. So ultimately in real life, we replaced them with digital cameras, Hubble Space Telescopes looking down. And in fact, the Hubble Space Telescope was probably just a leftover one of these. So they're like, hey, NASA, you want one? NASA got like 15-year-old leftovers, and that's the Hubble. So I don't know how much the NRO has looking down at us right now. So the idea for MOLE was you launch basically a Gemini, and your 2 astronauts, they climb through a hatch in the heat shield, which was fine. We tested it, it's fine. You can have a hatch through your heat shield. And because there's people up there, they would know not to take pictures of clouds. So MOLE went a long way. It was developed quite a lot. They were getting ready to launch. It was canceled in summer of '69, and the first manned launch was supposed to be in '71 at that point. So they got really close. There are a lot of astronauts in the program. This was like a big, well-funded program that got canceled kind of last minute. Bob Crippen was one of the astronauts. He would later be the right seater on the first space shuttle flight. There's also planning for successor moles, Block 2 and Block 3, and they're talking about like weapons and guns and survivability and some very Space War stuff. So if you're going with like a heightened Cold War space weapon alternate history, I don't know why you didn't do this. This would have been great. I mean, we did on the moon, but having these like manned spy stations, maybe you blow one up. Oh, did it blow up on its own? Was it sabotaged? I don't know. They've got guns on them, all kinds of stuff. The Soviets had their own plans for this. It was called Almaz. Became Salyut. The first space station ever was Salyut, and it was civilian. It had a gun on it though, space gun. Next thing I think could have been a cool incorporation was the X-20 Dynasoar, named for its dynamic soaring, which sounds like synergy buzzwords. So the Dynasoar was being developed. It's kind of like an upgraded X-15 space plane, a pilot. Maybe you could cram a second dude in there, or you got equipment. It could do recon, it could be a bomber, I don't know. It was being developed about the same time as Mercury was being developed. And it turns out that the space capsule, making a spherical or conical pressure vessel and cramming an astronaut in there is much more efficient than a plane, right? No big heavy wings. You don't need wings to land, you just pop a parachute, land in the water. So we ended up doing that. We didn't do the X-20. That didn't stop them from developing it further and constantly studying upgrades to it. Could have been weaponized, could have been enlarged. You could have made a crew rotation shuttle. Could have been, if you double the size of it, maybe you can get 5 astronauts in there, go back and forth to your upgraded Sky Labs spy station. So here's one of the cool things about the X-20 Dynasoar. Now when you're in orbit, everyone can see you from the ground. It's easy to track. So it's not like you're gonna sneak up on an enemy's space station or something. But the Dynasoar could dip into the atmosphere, use its wings to like turn using the atmosphere, and then pop back up, fire its thrusters to recircularize, and it could change its orbital inclination like drastically. So it could be like this very unexpected, surprising maneuver. So you dip into the atmosphere, you make a turn, then you pop up and you go after the spy enemy space station. That could be a cool, fun thing. We got guns on both of them. Oh my God. The Dynasoar program, real thing. Neil Armstrong was involved in it, and he was like developing the abort method. So I feel like that would have been a really cool addition. So we could have had like the X-20 or the HL-20, one of those kinds of shuttles instead of these real life space shuttles that don't make sense. The Russians developed the MiG-105. It's a fighter space plane thing. It's a MiG-105 in space, and they called it Lapat, which means shoe. So why haven't we been back to the moon since 1972? Why has it almost been 50 years? What have we been doing? Why did we make the space shuttle? Here it is. You ready? Let's do it. So NASA, the Apollo program, they're looking a few years ahead and going, well, what do we do after this? Are we going to keep making Saturn Vs? What do we do? They came up with a series of objectives. Here they are. They wanted a giant space station that could hold 12 people, and they wanted 2 of them. 2 12-man space stations. Basically, we're looking at like Skylab. They wanted 2 of them. Then they wanted another one in lunar orbit. So we're talking 3 Skylabs. Then a moon base. And then kind of working towards a Mars mission. So maybe we're assembling pieces, maybe a refueling depot or something like that to enable a Mars mission. They go to Nixon and say, this is what we want to do. And Nixon said, pick one. Also, they threw in a 4th option, did Nixon and the Republicans, which was we end manned space flight completely. Just shut it down. No more space flight for men. We could send up probes. Probes, but not men. Nixon, not a big fan of the space program and Apollo because Kennedy is the one getting all the credit for it. We choose to go to the moon. That's Kennedy. And if you recall, Kennedy defeated Nixon in the 1960 presidential election. Why is he going to keep funding a program that's like Kennedy's going to get all the credit for, right? So blame Nixon. So now NASA's faced with a choice. Like, all right, we're not going to be able to do cool, everything in the world. Our budget's getting cut drastically. So are we going to be this like limited thing? We just do one of these or one of those. What are we going to do? And they said, we're going to have our cake and eat it too. We're going to keep doing everything. So NASA's facing a new world where instead of time, a deadline, a decade, instead now it's budget. They're limited in money. So what do? Make it cheap, right? And so they said if we can make a rapidly reusable, so it's cheap, we can fly up once a week, then we can put up hardware, we can put up mass all the time, and then we can go to the moon, we can go to Mars, we can build a big space station, we can do all of those things. So it's kind of their cheat code to get around this budget cut. So when you launch a Saturn V, the only part that comes back is the very tippy top, the command module. Everything else is either left on the moon or in space, or crashed in the ocean or burned up. Not reusable at all. Now you could have tried to make it reusable. There's proposals to look at like flyback boosters, which is stuff like, you just put some wings on it and it flies back after it's, So say you got 4 space shuttles, each one can fly once a month, right? So you're having to launch a week. So first week you put up a lunar module, next week you put up a booster, third week you put up another booster, and then finally you launch like an Apollo. You put them all together, you go off to the moon. There's, you spend 1 month worth of your launches and you get a moon mission. Right? And you've got your shuttle. Next month you build a space station. And the next month after that, some Mars stuff. This is what we're gonna do. This is our cheat code. So NASA went off, started designing this, put out requests for proposals. All these companies are coming up with versions. And basically what they're looking at is a flyback booster, right? So instead of what we've seen now, we would have like basically 2 big planes. And there's one giant plane, something like a 747 size. It gets going, it's carrying the smaller orbiter. It goes to like Mach 6, detaches, the orbiter continues flying up on its own power. The big booster, Mach 6, 747, how hard can that be to make? That turns around, comes back, flies, lands. The orbiter goes to orbit, eventually comes back, also lands. So you've got 2 big parts. They both land on a runway at the end of the mission. You refuel them, it'll be like an airliner. Easy to do, bingo bongo. So they went to Nixon, they said, hey, this is what we're gonna make. It's like 747 goes Mach 6, and there's 2 things, and we need $12 billion. And Nixon said, yeah, sure, you can do it. You get $5 billion. Blame Nixon. So NASA had to cut costs. They couldn't develop both, so they decided to make the orbiter. But the booster thing, no, we went with solid rocket boosters that land in the ocean. The external tank burns up. So it's not nearly as reusable. Right, so now they're like desperate for money. NASA goes to the Air Force and is like, hey, Air Force, I know you want to launch a lot of spy satellites. We'll do it for you. You give us money, you can ride. We're going to be doing all these launches. You can ride on the back in our launch, get a free ride, right? So you like fund us. So here's what the Air Force wants. They would like you to launch into a polar orbit so that you can surprise the Soviets. They can't see this coming. You do some space shenanigans over like the North Pole or whatever, space laser deployment, anti-satellite missile, I don't know. And you don't do a full orbit, you just come back once around and you go land. Now, in that intervening period, while you've done an orbit, the Earth will have rotated underneath you. And so in order to land back where you started, where you launched, you need to fly laterally 1,500 miles. So to do that, you need big freaking wings, right? And the space shuttle that NASA wanted to make, their plan was a 400-mile cross range. Air Force wants 1,500, so you can see wings are going to get a lot bigger, and that's why early proposals will have much smaller, usually just like straight stubby wings, not big delta wings. Air Force also wants the payload bay to be a lot bigger than NASA wanted, so now it's bigger and longer payload bay, giant wings, much heavier, way harder to do. So NASA just is like, all these, oh, we gotta please the Air Force. So in For All Mankind, it shows a space shuttle that's identical to the real world one when they never would have made these design compromises. They have a huge budget. If they'd have made one, it would have been the flyback booster Mach 6 747. And if anything, they wouldn't have built a shuttle at all because they wouldn't have had their budget slashed and they wouldn't have done this Hail Mary pass of trying to have their cake and eat it too in a budget constrained world. They would have built Saturn Vs. They would have been doing the upgraded Saturn V route. When it was announced in 1972, NASA said the space shuttle would cost $10 to $15 million per flight, which in today's money is like $65 to $100 million. Again, like, no, wrong. And then they said it would fly 40 to 50 times a year, right? They're flying once a week, and they'd probably have 4 orbiters, right? When you're doing the math on how much it costs, a lot of these are fixed costs, meaning, you know, you've got your vehicle assembly building, you got these manufacturing plants that are making all the things, you got the salaries for all these people, the launch facilities. You just divide all of those by however many you launch in that year. So if you launch 50 times a year, then you get to divide the salary of all of those people by 50. If you launch once a year, you get to divide by 1. So the higher the launch rate, the cheaper it is. They were never, ever gonna hit this launch rate. It is insane that anyone ever believed that they would do that. I don't think they could pump out more than like 18 external tanks in a year. It wasn't gonna happen. So they build a space shuttle and they find out immediately the thermal protection system, these thermal tiles, super delicate, they fall off really easily. It's just like incredibly detailed, intricate maintenance, takes forever. Also, the space shuttle main engines, the RS-25s, need overhaul, and these are very super complicated plumbing. You're not just refueling this thing and taking back off. They actually flew the space shuttle from 1981 to 2011, 30 years, right? 40 a year, what were we talking, 1,200 launches? Sorry, we launched it 135 times. They're actually launching 4.5 per year, okay? Nowhere near that flight rate. So remember when we're doing all that math about how cheap it is and we're dividing fixed costs by 50 launches? 4. Okay, suddenly the price jumps, right? The full cost of the space shuttle program was about $200 billion. It comes out to about $1.6 billion per flight. So it ends up not being cheaper than Saturn Vs and all the Apollo stuff. It was supposed to be way cheaper than, right? So we developed and matured and figured all the bugs out of all the Saturn hardware, Saturn V, Apollo, and we just threw that all away, put shit in museums to develop something completely new and different that was not better, and in fact was worse. It was not better in terms of money, and while you're operating this heavy lift vehicle that puts 100 metric tons of stuff in orbit, which is not unlike a Saturn V, at the end of the mission, you gotta bring back the orbiter. So you operate a launcher that puts up 100 metric tons and you gotta bring back like 80 metric tons of it. You can't leave it up there more than a couple weeks. So you are going through all the trouble of operating a heavy lift vehicle with none of the rewards for it. And in addition, you can't leave low Earth orbit with it. So you're stuck in low Earth orbit with this thing that's a boondoggle. It was way more expensive than it was supposed to be. The NASA administrator in 2007, Michael Griffin, wrote an essay, which is sort of a fan fiction alternate history of what could have been if we'd have not gone with the shuttle. Let's assume that we had kept flying with the systems we had at the time, that we had continued to execute 2 Apollo lunar missions every year, as was done in 71 and 72. This would have cost about $4.8 billion annually. Further, let us assume that we'd established a continuing program of space station activities in Earth orbit built upon the Apollo Command Service Module, Saturn Ib, and Skylab systems. 4 crew rotation launches per year, plus a new Skylab cluster every 5 years to augment or replace existing modules, would have cost about $1.5 billion per year. This entire program of 6-man flights per year, 2 of them to the moon, would have cost about $6.3 billion annually. The average annual NASA budget in the 15 difficult years from 74 to 88 was $10.5 billion, 60% of it was the human spaceflight, so it was about $6 billion. There would have been sufficient funding to continue a stable program of lunar exploration, as well as the development of Earth orbital infrastructure, I suggest this would have been a better strategic alternative than the choice that were in fact made 40 years ago. Yeah, you mean like not ever going back to the moon for 50 years and having like a 5-year gap where we didn't launch anything into space? Could have been better. We didn't need to take that break and spend all this money developing something new that was worse. Ah, shocking. After a time as NASA budgets once again improved, we would have begun to concentrate on our lunar activity around an outpost. We would have used cargo missions to emplace the outpost equipment. A modified Apollo lunar module descent stage with extra fuel and cargo replacing the ascent stage. In other words, instead of the 2-stage lunar module, it lands and then returns. If you make one that's just a one-way it lands, you can make it a cargo lander, it stays there, starts building a base. The Saturn V could deliver 2 such vehicles with a single launch. So if you, instead of it was Saturn V and you get like 2 guys down to the moon for a couple days, if you did 2 Saturn Vs, you could have 2 cargo landers with all kinds of equipment and life support. Then the second Saturn V brings some dudes. They could stay there for like a month or something. Over time, we could have built up a lunar outpost or smaller ones at different places of interest. By the present day, using what we had with minimal modifications, and I will remind us all that the Soyuz systems of that era are still flying, we would have a vast store of experience, a significant amount of lunar infrastructure. When the civil space budget eventually improved as it did, we could have been well positioned to begin development of a Mars mission. And in the meantime, without doubt, we would have continued to modify, refine, and incrementally improve upon the old designs to the point where they would have provided greatly enhanced effectiveness by the present day. If we had done all this, we would be on Mars today, not writing about it as a subject for the next 50 years. So it doesn't take a huge imagination to come up with an alternate space history where we just don't do the shuttle, do something else, right? So the choice of the shuttle was naive, it was wrong, and ultimately deadly. Saturn V, Apollo. If the Saturn V blows up, the Apollo command module can be lifted off. There's a rocket on the top, a launch escape tower, and they'd be fine. Soyuz has it, Mercury had it, Space Shuttle doesn't. If an SRB fails, you're screwed. Thing blows up, they can't do anything. There's no ejection. Now at the very beginning they had ejection seats. Wouldn't have mattered if an SRB blew up, your parachute's not gonna work anyway. If your heat shield gets damaged, you burn up, there's Columbia. There's a lot of problems with the shuttle. Putting it side saddle on this rocket, not a good idea. This giant heat shield, it's very delicate materials, and it's next to this giant cryogenic tank covered in insulation foam that can fall off. So there's Columbia for you. Now it's true an Apollo command module has a heat shield, it could get damaged, but it spends the entire mission buried between the command module and the service module. The space shuttle heat shield is the size of 2 tennis courts. It's a lot of stuff to go wrong. And NASA had go fever. They thought they could solve every problem. They thought they would engineer it so it's so safe, and they were just completely wrong, overestimating how great they were. They're very proud of Apollo days and thought they could do no wrong. So Michael Griffin's, the NASA administrator, his thought experiment doesn't really go that far. He's just saying kind of status quo with the expenses. Doesn't really go into like alternate rockets or whatever. There's plenty of other routes of development. So for one thing, they're improving on the engines. The F1, the first stage of Saturn V, they're making the F1A, was cheaper, higher thrust, an incremental improvement. The big thing though is cheaper and easier to manufacture, fewer parts. The J2 engine, which powers the second and third stage of Saturn V, they're making the J2S, it was simplified, again, cheaper, small improvements in like thrust and specific impulse. So if you would have just built the next Saturn V with the upgraded F1A, the J2S, you could add even better payload to orbit. Then there's proposals to like stretch some of those tanks, because now if you have more thrust, you can make it bigger, you get more payload that way. There's people putting like different boosters on it, Saturn V with multiple solid rocket boosters. There's one where they're putting liquid fueled boosters with F1 engines on it. So they would make this 2 F1 engine booster and they'd have 4 of those. So there's 8 more F1s, around 5 in the core. We're talking 13 F1 engines that lift off. Enormous payloads. We're talking like, we're getting up towards Seadragon territory. So here's a big problem they faced. You've got a giant rocket, the Saturn V, that can put 140 metric tons into low Earth orbit. Here's your heavy lift. There's your thing that can go send a lot of stuff to the moon. And then they had the 20 or so metric ton to orbit Saturn 1B. Not a lot in the middle. So if you have a payload that's 40 metric tons, you have to use a whole Saturn V to launch that. So they kind of wanted an intermediate rocket. Can you do that with some of these cobbled together, right? So you've got these 2 rockets and you've got 4 different rocket stages. that are being manufactured. We're using 3 different rocket engines. Now, thankfully, the second stage of the Saturn I, third stage of the Saturn V were the same thing, so we've already got that commonality there. That's nice. Can we do more of that? So there's proposals looking at like, well, maybe we stop making the first stage of the Saturn V. These were called Saturn II because of the S2 is the second stage anyway. So then you take that second stage, the third stage, get rid of the first, and maybe you add boosters. And this looks a lot like a space shuttle or an SLS, the new space launch system. Your hydrolox engines in a big core, solid rockets on the outside, makes a lot of sense. Cheaper than the big F1 engines. You're taking advantage of the big dumb booster with your solid rocket boosters, right? There's ones where they take out the second stage, you use the first stage, the F1s, and then the third stage, maybe you delete some of those F1s, otherwise you're gonna have way too much thrust. There's some looking at replacing the first stage of the Saturn 1B with solid rocket booster. One thing they could have done is they could have gone with a modular system. So for example, the Falcon Heavy or the Delta IV Heavy, where you make a common booster and then you can strap 2 more on, and now you've got 3 of them, and so you've got your heavy lift and your regular lift, medium lift. You got both of those, but without making more things. You don't have the tooling and manufacturing to make multiple things. You just pump out lots of them, and then it's like, oh, this mission needs 1, this mission needs 3 of them, whatever. Much simpler, cheaper, you don't need all these factories, right? So if you make a single F1 engine booster, put an S4B on top of that, it's kind of replacing the Saturn 1B, that could put about 27 metric tons in the low Earth orbit. That's fine for your Apollo command module, your crew rotation to Skylab. Then if you want a heavier lift, you take 2 more of those boosters, strap it on, so you got 3 F1 engines. And with that, you've got about 60 metric tons to low Earth orbit, maybe 70. Maybe we have a bigger version of the S4B, maybe a lengthened one or something like that. You can finagle some of these things, and you've only got 2 rocket stages to make with 2 engines, not 4 and 3. If you want the big Apollo lunar landing, you don't need a Saturn V. You have this Saturn Heavy that's like half the payload of a Saturn V. You split your payload into 2 launches, send one up, then the other, they meet in orbit, then they go off to the moon. This is called Earth Orbit Rendezvous. It was one of the methods they were looking at before they built the Saturn V. One of the reasons they went with Saturn V is they were concerned about Earth Orbit Rendezvous. What if you launch half your payload and then something goes wrong? There's a storm, I don't know, and you can't meet your launch window, and this thing is just waiting. So just having them both in one rocket seems simpler. So one point of divergence you could come up with is if they just didn't go with the Saturn V, if they went with Earth Orbit Rendezvous and they had a little bit smaller rockets, then we wouldn't have to do this big jump back to a modular smaller one. So if you're a nerd and you go on internet forums, lots of alternate history. So there's one particular one that's called Eyes Turned Skyward, which is based around this evolution of Saturn hardware into what they call a Saturn multibody, which is basically the Saturn Heavy concept. And it's basically, if you were to go read like Apollo 14's Wikipedia, then Apollo 15's Wikipedia, it's like that, it just keeps going. Apollo 19, Apollo 20. Pretty dry stuff, but they do some projections. Oh, this person wins the presidential election. Alternate takes on like what the Soviets do. Maybe they don't do Buran because we didn't do the shuttle. Maybe the Europeans go and make their own something. So there's all kinds of alternate histories. So Eyes Turned Skyward, they're in Kerbal Space Program. There's mods of the Eyes Turned Skyward ETS Saturn multibody. You can build it in there, it's great. And if you look here, you can see here's an alternate history written in 2014, which has the Soviets winning the moon race. And oh, what would that do if the Soviets landed on the moon first? This is well before For All Mankind. So this isn't like a crazy groundbreaking idea. And to me, it's really kind of shocking it ever got made. Just that like, this great nerd thing I used to nerd out on, like reading alternate history forums for alternate space flight history. That actually got made, it's crazy. It's designed for my brain specifically, and then they do technical things wrong. They have the space shuttle go to the moon. It's like, what is your audience, man? If it's me, like I'm gonna notice that. So it's a tough crowd. Also worth noting, The Simpsons is an alternate space history, because Homer goes to space, and he does so in a weird shuttle that's not the shuttle, and it's launching on what looks like a Saturn derivative rocket. If anything, it looks like one of the Saturn II proposals with SRBs around an S2 stage. So the Simpsons are doing it. So another route, you go the same modular concept as Saturn Heavy, but instead of a 1 F1 engine, you go with 2 F1 engines, a little bit chonkier. So this was studied in the 60s, and the program was called the S1C-TLB Boeing Low-Cost Saturn Derivative from 1967. And they said it could put up 39 metric tons That's with a 2 F1 engine booster, S4B on top of it. Now, if you do a heavy version, now I didn't see in there that they studied the heavy, but if you did, I did the math, you could get about 90 metric tons. Pretty good. We're getting up to Saturn V territory. If we start stretching tanks and, you know, making a bigger upper stage and improved tooling and then like common bulkhead, there's a lot of things they could do. They would later study this again in the 80s. So in the 80s, after the shuttle was clearly not working, Challenger, they were looking at like, maybe we need a different booster in order to heavy lift stuff, because the shuttle's not really great at heavy lift. It's good at heavy lift, it's just mostly lifting itself. It's like a fat person doing squats. So I looked at this in the 80s and they came up with a proposal, 2 F1 booster engine, and they called it Jarvis because of Greg Jarvis, who was an astronaut who died on Challenger. So we go with the Jarvis and the Jarvis Heavy. Could have gone that way, so you have 2 to 6 F1 engines. So Michael Griffin, remember he came up with a not very imaginative status quo of Saturn V, Saturn 1Bs, and it was still like, yeah, we can do Skylab and keep updating it and improving Skylab and more Skylabs. Also 2 lunar landings a year. Well, we could do better than that because this would be a more efficient system. You can still do the Apollo lunar landings, it would just take multiple launches. Now remember I said I basically wrote this. So I did write an outline for my own little alternate history. I never bothered with the whole multiple Wikipedia pages of every mission. I never really wrote much about it. I didn't do much character work. But here you go, here's my scenario, alternate space history, let's do it. So John F. Kennedy wore a back brace, he had chronic back pain. And when he was assassinated, he was shot first, about here, the neck comes out about here. It's not clear that that would have been a fatal shot. Because he's wearing a back brace, after he's hit, he bends over, but he doesn't bend over very far. He couldn't slump. And so the third shot gets him in the head. If he's not wearing the back brace that day, if he just didn't wear the back brace that day, maybe the first shot, of course, if we're changing the back brace, maybe the shot's a little different so we can finagle it that way, but the first shot doesn't kill him, and then he slumps over. Oswald misses on the second shot on the third shot, and Kennedy lives. What happens now? Well, Oswald was a defector. He defected to the Soviet Union, then came back, still like got in the country. Like, how do you guys let this happen? So maybe Kennedy thinks this is a Soviet plot. Maybe he goes paranoid about the Soviets. They tried to kill him. So in my story, we've got like a very paranoid JFK, thinks the Soviets are out to get him. It doesn't get involved in Vietnam as much, pulls out because he doesn't want to be entangled there. Might entice the Soviets to attack somewhere else. So he's investing in like space spying, space weapons, the Dynasoar mole, super mole, Skylab mole, extra moon base, who knows? So we get a, just like the For All Mankind kind of thing of like more funding, maybe moon base. So I wrote this in 2014, this outline, and I have JFK is reelected in '64. He has a falling out with Lyndon Johnson because Johnson wants to ramp up Vietnam and Kennedy like shuts him down. They become like rivals. '68 election, is it RFK versus Nixon? Is it LBJ versus Nixon? I don't know. Vietnam's not a big issue. So you can go a whole different route that way. And then the big thing would have been very Tom Clancy techno-thrillery about like maybe a Soviet space shuttle defecting. You're thinking like Hunt for Red October. We've got spy space stations with weapons, some kind of space techno thriller moon base, something like that. For All Mankind, it really is kind of in this wheelhouse of what I was writing. So I really didn't write much of it. I was like, so this wouldn't work as a screenplay. It's too detailed and it's like, it would work as like a Tom Clancy-ish novel, and it would work as like a mini series. But I don't know if you know this, if you're a screenwriter, you're trying to make a TV show, you don't write a whole season of a TV show or multiple seasons. You write a pilot, you write one episode, you try to get that made. Any work you do on episodes 2 to whatever, no one's gonna read those, right? So even if you get picked up, even if someone like buys your pilot and you're like, hey, I've also written more episodes, they're gonna be like, well, we're gonna put a writing team together and we'll work on it, and they're gonna throw those away. Like TV, they're not making it. Don't work on episode 2 of your TV script. So basically, if I'm not writing a Tom Clancy-ish novel, and if you're doing a TV miniseries, it's even shorter. I'm not gonna write 10 episodes of something. No one's gonna read past episode 1. So I just never bothered, never really went into detail. And I'm kind of amazed that this ever got made to begin with. But I could see why it gets picked up. The pilot's pretty eye-grabbing. This shocking hammer and sickle on the moon. Okay. Also, I had in my notes that there's a big solar storm in 1989. And I had, what if there's a moon base then? right? And maybe all their electronics get fried. We have like an Apollo 13 situation with our moon base. Kind of happens in season 2, although it's not in 1989, so I don't know if there really was one then. Maybe that's coming up in season 3, the big 1989 solar storm. So instead of writing that alternate Apollo, I called it Beyond Apollo, I think. I don't remember. Instead of writing that, I wrote dick joke comedies. So I did that for a while. So I did write a screenplay that's spacey. It's about the moon landing hoax. It's been set in a world where like, hey, what if the conspiracy, they faked the moon landing? If that conspiracy is real, like, what other conspiracies are real? Like, who killed JFK? Maybe nobody. Maybe he's not even dead. What? The CIA has gay bombs, LSD brainwashing. So it's a comedy with all these crazy things going on in a crazy conspiracy world, kind of making fun of like conspiracy theorists and flat earthers and stuff like that. Remember when that was fun? Anyway, that script is called Mooned, and it twice was a quarter finalist in the Nickel, which is like the top screenwriting competition. If you want to read it, send me an email, I'll send it to you. It's not getting made, so there you go. So, long story short, if you need a screenwriter for your Apple TV series about alternate space history, if you need a screenwriter who knows screenwriting things and is an English professor, and also can do delta V calculations and can tell you, you know, how your rockets don't make any sense. Hey, what's up, girl? Hey, baby. So if For All Mankind had hired me, I could have pointed out their terrible inaccuracies, and they would have told me to shut up, because I'm pretty sure they knew, or they had an advisor tell them, and they wanted that nostalgia cool factor, and they were gonna just make it be the space shuttle and not the HL-20, because nobody knows what that is. Even though I think it would have worked. It would have been cooler. I'm gonna make an alternate version. I'm not really. Somebody else make an alternate version, go cut into For All Mankind, and just any shot of the space shuttle going to the moon or whatever, just replace it with the HL-20, do some CGI, it'll be great. I approve. So any critique anybody has on their technical things, they probably knew, and they're going for the nostalgia or that retro factor, and I think the HL-20 could have worked. It looks pretty retro, so I would have argued for that. Ronald Moore, come at me. That would have been a better choice. Makes more sense. And it's retro cool. It's like the space shuttle in The Simpsons. That's cool and retro now, right? It doesn't need to be the big stupid space shuttle. But that's Hollywood or Apple TV, I don't know. They don't care about accuracy, right? And this is the lesson. It's better to be sexy than accurate. If you've got a script and it's like all these technical details, you did your research, you did the math where you had to, you got all that stuff sorted out, it all makes perfect sense, it's great, working, everything. And then over here is another script, which is similar and on a similar topic, but this person didn't do the math, it gets all these technical details wrong and it's dumb, but it's 2% more exciting than yours. They're going with this dumb one instead, which is why I didn't bother writing this, because my entire interest in writing alternate space history, which I ultimately didn't write, all of my interest in that is in like, will it be 80 metric? Oh, can I do the 90 metric? What if they do cross-feed fueling? I gotta do some more math. And that does not overlap at all with a script reader, which is weird because I am a paid script reader. Technically correct doesn't get you anywhere. So wow them with the story and the images, cool factor. Don't worry about the minute details. And that's the lesson. Even when you're making space nerd stuff, it's more important to have good characters, exciting story. It's not so important to do the delta V calculations. A screenplay is not a physics problem.
Solids could be shipped by rail. I say it another way, the diameter of the solids was set by rail shipment. Rails of the American rails are set first by the British. We brought the British rail system to the United States. The British rail system was set by the width of the wheels on the carts that they used to have, and the carts' width was set by the Roman chariots that used to be on the roads in England, because they made grooves. The Roman chariots' wheel width was set by 2 horses in front of them. So there's some who say that the diameter of the shuttle rocket engines was designed by 2 horses' asses. Those are the guys that wanted to use liquid.
Or they wouldn't have even built the shuttle at all because they're not. Cuts off their lips and anuses and then like puts them in. Easy to do. Bingo bongo.